Okay, today we will be discussing 2010 Physics MCQ paper and without any further delay, we'll start on with the first question itself. The dimensions of moment of inertia is when considering the equation which we are expected to write when identifying the moment of inertia of object is we use the equation I equals mr square. So here we need to find the dimensions of I, and dimensions for m is capital M into simple r, in the sense it's a length, dimension is length, m and square. So the answer is ml square. For the first question, the answer is number 1. Question number 2. SI unit of the quantity of heat. We know that heat is an energy, so the unit is joules. Since heat is an energy, we measure it in joules. The answer for the question number 2 is number 4. When light passes through a glass prism, which of the following colors deviate the least? That's question number 3. You need to identify that the highest deviation is for the purple color. The least deviation is for the red color. These are the points that you must remember or need to write this down somewhere. The highest deviation is shown by purple color. I better reduce the thickness. And the least deviation is shown by red color. The deviation of the remaining colors can also be compared. That is, orange has a less deviation than yellow, and green has a greater deviation than yellow, and blue has a greater deviation than green, and indigo has greater deviation than blue. Question number 4. The distance from the eyelids to the retina of a person is 1.7 centimeters. The focal length of the eyelids when the eye is in completely relaxed position. Here our eye is completely relaxed. So when we observe that the object is kept infinity, it means that these rays are parallel. So at this moment, the image is formed at the focal point of the eyelids. And whatever the situation, the final image should form at the retina of the healthy eye for all objects. So the focal length of the eye is the distance between the eyelids and the retina. Here the focal length is the distance between the eyelids and the retina. That is 1.7 centimeters. Answer for the question number 4 is 4. Afterwards, we shall move on to the fifth question. Question number 5. Consider the following statements made about a voltmeter and an ammeter. A voltmeter has a large internal resistance and an ammeter has a small internal resistance. What do you think of this statement? According to theory, we know that voltmeter must possess a larger resistance, whereas ammeter should possess a very small resistance. So the statement A is correct here. the resistance of a voltmeter should be very high and the resistance of the ammeter should be very low. I'll write that point separately. For a voltmeter, there should be high resistance. For ammeter, the resistance should be low. That is of the statement A. Let's go to the statement B. A voltmeter is connected in series with the circuit component to measure the voltage across the components. So what is the theory part behind this? We already know that we connect voltmeters in parallel series, whereas we connect ammeters in parallel connection, whereas ammeters in series connection. So I'll write that point separately again. Voltmeters should be connected in parallel connection. Whereas ammeters in series connection. Okay, series connection. Now let's move to the number 6. Two guitars of wires A and B, identical in all respects except that the diameter of A is twice the diameter of B and are subjected to the same tension. The tension is same tension. You don't need to write these like this, but for better understanding, I'll better write these special points in separate manner. So they said that there are two wires as A and B. The diameter of A is twice the diameter of B. If diameter of B is dB or whatever, A is twice that dB. So we need to write the ratio of fundamental frequencies of A and B. So if I draw a string like this, guitar string is like this, and it's subjected to tension and of length L, and let's consider that there are two wires now. So there are two wires, so I'll get on with the equations itself. Let's say that L is for A, lambda A divided by 2, for B, lambda B divided by 2, so lambda A equals to 2L, whereas lambda B also equals to 2L. And so we know the very common equation that V equals F lambda, and we know that V equals to tension divided by mass per unit length, and this mass per unit length can be written as A rho. Okay, and so I'll substitute that part here. A rho root lambda F is F itself into 2L. So we'd better write this for the two strings. For the string A, T divided by area of string A into rho square root into FA into 2L. For string B, I can write tension divided by AB rho into FB into frequency of string B into 2L. Afterwards, I'll name this as equation number 1 and this as equation number 2. Afterwards, if we divide this, for area, we can write that area is actually, for a wire it's pi r squared, no? Pi r squared. So actually pi r in the sense is dB divided by 2 squared. For the string B, so AB is this one, area of string A is pi into give me 1 second, because the string A has a diameter of 2 dB. 2 dB, so substitute twice dB here and divided by 2. So in equation 1 we can write as the area as pi to pi will cancel off for sure, that dB 2 dB divided by 2 squared into rho, right? So square root the whole thing, FA into 2A. For equation number 2, T divided by the area of B is dB divided by 2 squared into rho. Take the root of it, then FB into 2L. So afterwards you can see that this is T divided by 4 divided by 2 is 2 dB squared into rho, and square this off to remove the square root here in this step itself. Here it will be FA squared into 4L squared. This is equation number 1. Again equation number 2, we'll say it's T, remove the square root, and dB squared divided by 4 into rho, and equal to FB squared into 4L squared. Afterwards we better divide equation number this is for A, right? For A is, this is for string A, this is for string B. So string A divided by B. So equation 1 divided by 2. Here T two dB squared rho divided by 2. I can't let this take upside down, or else I'll write it like this. T divided by dB squared into rho divided by 4 equals to FA squared into 4L squared divided by FB squared into 4L squared. And then can say this T to T, we can write this part and like this, okay? 4T divided by dB squared into rho, this way. Then I'll write the same thing here, T 2 dB squared rho. I brought this part to here, then this part simplified turns out to be like this. Then turn this upside down because we are dividing, dB squared into rho divided by 4T, and then here 4L squared cancels off, and what were remaining is like something like this. Then rho to rho cancels off, T to T will cancel off. Afterwards dB squared will cancel off, and so what are remaining is FA squared divided by FB squared. You are remained with 1/4. So thereafter FA divided by FB, frequency of string A divided by frequency of string B, is equal to half. The answer is number 2. Now we will move on to the seventh question. Question number 7. In order to double the root mean square speed of an ideal gas, the factor by which the absolute temperature of the gas to be increased is, so we have to first identify the kinetic equation of an ideal gas. I'll revise some theory parts here. But though there are short tricks and short ways to do this problem without revising these major theory parts, but it's better to identify or revise all these points in this place itself. So I'd better write down the molecular kinetic equation for ideal gas, that is PV equals, this is a famous equation and you will find this in chemistry as well, M capital N C bar squared. Here P and V are pressure and volume of the gas, and M is the mass of one molecule of gas, and N is the number of gas molecules, and C is the speed of the ideal gas. So C bar squared is root mean square speed is just C bar. So we have another equation for ideal gas, PV equals nRT. Let's consider as 1 and 2. Here you can see that 1 over 3 mnc bar squared equals to nRT. And here you can see there is a relationship as C bar squared is directly proportional to T. Therefore, let's say that this C bar as V. Let's consider this C bar as the velocity represented as V. And we know this common equation that V is directly proportional to root T. This of course is a very famous relationship. This T is not just the temperature, but we call this as absolute temperature. So what is it? V is directly proportional, velocity of gas is directly proportional to the square root of absolute temperature. Afterwards, I'll take this into two equations because they are asking the scenario in which the ideal, the scenario in which once the root mean square speed is doubled, by what factor the absolute temperature will change. So we need two relationships here. So I'll take one relationship as V1 equals, I'll apply a constant to remove this directly proportionality constant and take this temperature as T, and they say in order to double the root mean square speed is this particular C, that is V. To double it in the sense 2V1 equals K is a constant, and what will be the T dash value? Let's take this T1, let's take this T2 value. What they are asking is by which factor would T2 be changed. Okay, this is what they are asking. So again these are two particular equations, and we'll divide 2 by 1 so that we can directly subject T2. 2 divided by 1 is 2V1 divided by V1. Avoid K because it will get cancelled off during the simplification. So T2 root divided by T1 root. So V1 to V1 cancels off. So T2 subjected, you get 2 T1, that is T2 equals 4 into T1. So 4 times is the factor by which the absolute temperature of the gas is increased. So answer is 3. Now we'll move on to question number 8. Question number 8. If the angular velocity omega an object varies with time is shown in the figure, and the corresponding variation of angular displacement theta with time t is best represented by. The best way for you to detect this concept or comprehend this concept is, we very well know velocity versus time graphs and displacement versus time graphs. That is in the sense Vt and St graphs. So we know this concept. This is a short trick for you to identify the graphs within a short time period. This in the sense, I'll change the color. Oopsie. I'll change this to light blue. This is not the answer, but the way of approaching the answer. So this you see the way that this curve is drawn, the gradient should be positive, right? You know very well that positive is like this. No, this is positive, and if other side the gradient is negative. So here positively decreases. Okay, this is positively decreases, and this is positively, this is also positive, the gradient is now this way also, the gradient is positive. Okay, this way also gradient is positive, so positively increases. Here this all lies, this is towards this side, and this side, this is the gradient is negative gradient. Here negatively increases, here negatively decreases. So remember this part very thoroughly. And now we'll move on to the answer. So let's draw this Vt graph first, not as in the question, but to see the observation once we apply this to Vt graph. So they have the angular velocity they have given, so just insert normal, like just the velocity without the angular velocity, so that you can easily grasp the concept. And the line is like this, a straight line, y equals mx line. Here this is positively increasing graph, right? Positively increasing graph. Positively increasing graph is this one. So this is the way of drawing ST graph. So ST graph can be drawn looking at the trick we drew above. So ST graph, we draw it like this. So similar concept. Now this is the Vt graph, this is the St graph. So now convert this to omega t graph, angular velocity time graph, and the angular displacement versus time graph, that is theta t. So just apply the same scenario here, same graph for omega t, that is like this. Once you convert into angular displacement, it will be something like this. What you need is to just change this velocity into angular velocity. The concepts are the same. So theta into t. That's also the answer is number 5. Answer is 5. Now we'll move on to question number 9. A major artery with 1 centimeter square cross-sectional area carrying blood branches into 18 smaller arteries, each having a cross-sectional area of 0.4 square centimeter and carrying equal volumes of blood per unit time. In this case, they are talking about a specific artery and a small artery, which the main artery is a collection of 18 smaller such minor arteries. Okay, so that's a main artery. Let's call it question number 9, major artery and a minor artery. Major artery. So in the major artery, let's say the velocity of blood passing through the major arteries V1 and of the minor arteries V2, and the blood volume per unit time in the major artery let's consider as Q1, and blood volume passing per unit time in the 18 smaller arteries let's consider as Q2. So what is this Q actually? Let's define the Q, because some guys are having problems on defining what is Q and so on like that. So big problem. The blood volume here, according to this question, the blood volume, you can apply this concept for whatever the situation it is. So here the scenario is the artery scenario. So blood volume per unit time is given by Q. So that's just for understanding. Okay, so we know the famous equation we've seen in mechanics, and when solving problems related to mechanics, this equation is quite common. That is Q equals what? AV. Q equals AV. So this consists of two scenarios, like the major scenario and the minor scenario. So how many minor arteries is a major artery? 18 minor arteries equal to major artery. So here Q1 equals to 18 into Q2, right? So Q equals AV. A1, here the area of major artery I will also consider as A1 and A2. A1 V1 equals 18 into A2 V2. So let's apply the data. A data for the area, cross-sectional area of the major artery is 1.0 square centimeter. Centimeter squared will get cancelled obviously, so no need of the process of unit conversion in this question. So into V1 is not given, only the area values are given, only the area values of A are given, into 18 into A2. A small artery is of 0.4 square centimeters into V2. What they are asking is again a ratio. So that is speed of major artery. So what is the major artery is V1. So they are asking V1 to V2 ratio, right? So V1 divided by V2 is 18 into 0.4 divided by 1.0, that is 7.2. That's all. So the answer is number 3. Question number 10. It comes under oscillations and waves in wave properties, and a figure shows a wave pulse traveling along a string towards its end, which is connected to a small light train that moves along a vertical wire. Which of the following figures best represent the shape of the wave pulse at the instant when the peak of the pulse reaches the rim? So the rim moves upwards, right? When the pulse comes to the rim, Here the 3, 4, 5 choices can easily be eliminated. The amplitude is a unit of measuring the energy of waves, right? You obviously know that. So energy cannot be destroyed. The energy can be conserved or either be lost. So it cannot be increased. But the reflected wave of the half pulse without a phase change can combine with the remainder half pulse. So that makes it turns out to be of a higher amplitude. Okay, so the answer is actually 2, not 1, because it becomes double due to combination of the wave pulses, as it is a half pulse once it reaches there. So the amplitude increases. So the answer is number 2. So that's not a big deal, I suppose. Question number 11. Very tricky. Point object O is placed in front of a thin convex lens as shown in the figure. The refracted path of incident rays shown is best represented by. So here the object is kept inside the focal length f, right? You can see it. You can see it here. So the image is virtual, upwards and enlarged. So we can draw the line. Give me 1 second. Okay, now okay. See the color. I have no idea what's going on. Let's check what's wrong here. Choose right. Yeah. Okay. So here we can say that the object is placed here. From the object, we'd better draw a ray from the focus, and so I'm sorry about the straight lines. From there we can extend this line. This gets connected like this. Okay, so here we can draw the light rays on the paper itself. First we can draw the light ray through the optical center. It doesn't get refracted, and we can identify the intersection points for all the diagrams. So the answer only image is in the fourth one. So intersecting point is at the left side of the lens. So image is virtual, upwards and enlarged. Thereby the answer is obviously 4. Now we'll move on to the next question, that is with related to cell systems in current electricity. The current through ammeter A of the circuit is shown in so we'll have to use the Kirchhoff rules here. It's better to draw the circuit, or it's just drawing in here itself. I'll take a good color so that the way the current flows in the diagram is clearly visible. So considering question number 12. Considering the A, B, E, F, A loop, so we'll have to just name the diagrams. Okay, the way I draw here, name the corners here would be A here, then B here, C here, D here, E here and F here. So that's the direction in which the current flows, like this, like this, like this, like this and like this. So first let's consider the A, B, E, F, A route. A, B, E, F, A route. Here the Kirchhoff rule states that the summation of EMFs is equal into currents into the resistance, E equals IR. So sigma E equals to the IR summations. We can just say towards this direction. Here the current enters like this from the positive terminal. Actually, if the current exits through the positive terminal only, it will become a positive E. Here, since the current is entering from the positive terminal of the cell, it will become a negative E. IR product will be a negative E. Afterwards, let's go travel along the path. Okay, here there's another cell. You see here. Here it enters from the negative terminal and exits from the positive terminal. What I said before is that if current exits, goes away from the positive terminal in the sense is, that is a positive E. That is a positive E. So the total is 0. Total EMF is 0. Now we will consider another route, that is ABC DEFA route. ABCDEFA route. They are also the same scenario. Let's check. Starting from A, we go like this, like this, like this, and then enter from the positive terminal. Enter from the positive terminal. That is a negative V. Obviously a negative V. Then again continue our journey from there. Then you exit from the positive terminal. Exit in is positive from the positive terminal. So summation is again is 0. Now let's consider another part to assure that our summations of electric potentials is equivalent to 0. So another path is the path from B, C, D, E. There also summation equals, let's start the journey like this, enters from the positive, that is negative V. And again here exits from the positive terminal, that is again a positive V. Totally 0. That's obvious, right? So therefore no current flows through the resistor or any cell. There is no current at all. This I is 0. Though there are resistances fixed, there is no current passing. That's why the EMFs are, in all the cases, it becomes 0. So the answer for the 12th one is answer 1, that is 0. Question number 13. A coil made of platinum wire has a resistance of 50 ohms at 0 degrees Celsius. When immersed in melting lead, the resistance of the coil increases to 115 ohms. If the temperature coefficient of resistivity of platinum is 4.0 into 10 to the power minus 3 Celsius minus 1, the melting point of lead is what? So just write down the data you have. Just write down the data you have. Get down with the data. Question number 13. Platinum wire has a resistance of 50 ohms at 0 degrees Celsius. When immersed in lead, the resistance of the coil increases up to 115 ohm. Melt in lead. So thereby the temperature should be increased, because it says when immersed in melting lead. And also if the temperature coefficient of resistivity, that means alpha is 4.0 into 10 to the power minus 3 Celsius minus 1, then the melting point of lead. This is what they are asking. So we need to take this into our equation. We know that resistance in this is of two scenarios. R2 equals R1, this is the initial, into 1 plus alpha delta theta is the major equation that we are using here, right? So let's write two equations. We can write or else we'll better use the two scenarios, substitute them in this one equation. Final part R2 later we get in the case 2, or afterwards in our second attempt we get 115 ohms. Initial resistance is 50 ohms. 1 plus alpha value is given, 4 into 10 to the power minus 3 into delta theta. Actually the case, this is for the situation 1, situation 2, no? So situation 2 minus situation 1. Here let's say here the temperature is T, unknown temperature is T. So T minus initial temperature is 0 degrees Celsius. So what we get here, the answer is in terms of Celsius. Okay, always keep in mind of the units that you are using. Sometimes the answer might have been given in Kelvin, but in this case there is no problem. Don't worry, no need to worry about that here. So here let's simplify. 115 equals 50 plus 50 into 4 into 10 to the power minus 3 into T, and here subtract 50, then that is 65 into 200 200 into 10 to the power minus 3, this whole part is 0.2 t. Then t equals 65 divided by 0.2, that is 325 degrees Celsius. So answers are already there in Celsius. So just underline 325. Question number 14 comes under the galvanometer part in current electricity. Here they say the circuit shown in the figure is constructed using ideal components. A is an ammeter and V whatever it is, V is a voltmeter. If a student by mistake replaces ammeter A with the ideal voltmeter Vy, then Vx and Vy respectively read as what? A is the ammeter, Vx is the voltmeter. By mistake, the student replaces the ammeter A with an ideal voltmeter Vy. We can substitute an ideal voltmeter for ammeter A, but there is no path for the current flow because an electric current doesn't flow through an ideal voltmeter. Therefore, we know that ideal voltmeters usually have very high resistance. Resistance is extremely high, whereas the current thereby becomes zero. Where actually it means that resistance goes up to infinity. As a result, current is zero. That means no current flows through the system. Therefore, the readings of the two ideal voltmeters are 2 volts, and that the EMF of the cell, that is the EMF of the cell itself. Unless there was a cell in the diagram as 2 volts, as you can see here, unless this was there, the voltage is actually 0. But since 2 volts is here, no current. Since 2 volt is here, current does not pass through the system, no. Thereby volts are just 2 volts. So for Vx it will be 2 volts and Vy also it will be 2 volts. Answer is 5. The same values as the EMF. Next question comes under matter and radiation, the radioactivity part. Under radioactivity, there is a nuclear reaction given. So better write down this nuclear reaction in your sketch paper. So 15 question. Here this 7 3 AXZ gives A plus 6Y Z plus 2 plus A. Particle denoted by A. They are asking what this A is. So we first of all the concept behind this is balancing the LHS and the RHS values for the atomic numbers as well as for the mass numbers. So according to mass numbers, let's first consider the mass numbers. Let's balance the sides. So for A also there is we don't know the mass number y and then the atomic number x, we are unknown. They are unknown terms. So we need to find these y and x values and ultimately determine what this A is. Without the y and x, so one might think that since A is given in just A and that means both mass number and atomic number are 0, you can't consider because we are asked to find what A is. So A is in the format of having a mass number and having a specific atomic number. So you need to define those variables by applying your own variables. So that means you can insert in the yx, whatever it is, You need to find y and x at first. Thereby come to a conclusion that this could be a proton, this could be a neutron, this could be an electron, whatever. So let's balance now. 7 plus a equals a plus 6 plus y. A to a cancels off and this y is equal to 1. Then come to atomic numbers. 3 plus z equals z plus 2 plus x. Z to z cancels off. X is also equal to 1. That means this A is something like this 1 1. What is it? Mass number 1 in the sense and atomic number 1 in the sense. This is a proton, right? Proton. So the answer is 1, a proton. Question number 16. A small conducting sphere of mass m has a positive q charge. This sphere is hung from an insulating thread of length L in a region where there is an electric field of intensity in vertically downward direction. In addition to the gravitational field, that's highly important because you might lose the gravitational field in your equation, and is allowed to oscillate as a simple pendulum. If the period of the small oscillations of this simple pendulum is t, then what the heck is t? So G is the gravitational force on a unit mass. We already know that. The time period capital T of a simple pendulum is given by. Just revise your waves and oscillations lesson, and these are the equations that you have to apply in answering this particular question here, though it is dealing with electrostatics. So here let's revise the equation that T equals to 2 pi L divided by G. You already know this. The time period of a simple pendulum. Since the static force exerts on the object, it is EQ, right? Static force exerted on the object. We know that static force equals EQ. Here capital E, already E term is given here, and Q, positive Q is given here. That's fine. Then we can calculate the electric force on unit mass. So this is just the electric force exerted on the object. But what we need is the electric force on a unit mass. The electric force on a unit mass. Because it says mass m. Electric force on a unit mass, that is EQ divided by m. They said that a gravitational field is in addition there is a gravitational field acting in the system. So the total resultant force in the sense is just the resultant force. Total force acting is something G plus EQ divided by m. Not just this part. Additionally, there is a gravitational field, you see. So the new time period. Now substitute this data to this particular equation. We need the new time period. Though this was the time period for a simple pendulum, now the scenario has changed. You see there are electrical forces acting, gravitational force already acting, plus something additional is here. So T dash equals 2 pi L divided by G plus EQ divided by M. This whole thing square root. This is the answer. So just see whether there is such an answer exists in here. Yes, that's answer number 5. Next, question number 17. Two stars A and B of uniform density have equal radii. Just get on with the data, then it will be easier to continue. Question number 17. There are two stars A and B of uniform density D having equal radii r. Star A having twice the mass of star B. Mass of star B is mb and A is said to have twice of mb. Is spinning 3 times faster than star B. It is said to be spinning 3 times faster. So if the velocity here is v, star A having twice the mass of star B is spinning thrice the velocity of B. So this is the data. Now this is something we're dealing with, the moment of inertia. The angular moment of star A, what they're asking is angular moment of A divided by angular moment of B and what that ratio is. So we'll see that I equals inertia of a sphere. Inertia, stars are joint spheres. Inertia of sphere equals to 5 divided by 2 mr squared. So let's consider for star A, the inertia IA is 5 divided by 2 ma actually is that is ma into ra squared. For inertia of B, 5 into 2 mb rb squared. So divide 1 by 2 so that we can come to a relationship afterwards. That's why we are dealing with these equations. So 1 divided by 2, that is IA divided by IB. IA 5 over 2, 5 over 2 cancels off. What is remained is MA divided by MB and RA squared divided by RB squared. Afterwards, we know that the radius is equal. This is RA, let's consider RA, RB. Radius are equal. So this actually is something, let's say R, that's also fine. Here this is actually R squared divided by R squared. So that is 1. Okay, so what you are remained is with something, and IA actually divided by IB, we said there was something of a difference in the masses, right? It was said that A is twice MB, so just substitute 2 MB divided by just MB. MB cancels off, that means you get the ratio as IA divided by IB is 2. This is what relationship you get in here. So next they are talking about the motions of this rotational motions of this stars. So the motions can be expressed V equals R omega. So for A star we have V velocities. For A star we said that beforehand, according to the data we had, it was said that the velocity of A was thrice. You see, velocity of A is thrice. I just want to show that the data we applied is really helpful when doing the simplifications, because afterwards you might have forgotten how much times this was than the other one. So just 3v equals radius is just r according to the data we applied, simple r I applied. So omega is what we need to find, omega a. This is something we need to find, so let it be there. Then for the star b is just v, velocity is just v, then r is same, we need omega b. So these are also two particular equations, but we have this valuable term omega b, that these angular momentums. Thereby we can angular velocities on the afterwards. Once we have found out the angular velocities, we can build up the angular momentum by using this data. So my ambition or main target here is to divide, since ratio a over b is what is ours, I'll prefer dividing 1 by 2. So 3v divided by v is omega a divided by omega b, v to v cancels. So again we come to a relationship as omega a divided by omega b gives 3. Okay, we have two valuable relationships to build up the concept of angular momentum of star a divided by the angular momentum of star b. So next we'll build up or identify what angular momentum, what is it, what equations do we apply here. Angular momentum is actually p equals I omega, like just normal, just the momentum is p equals mv. Similarly in angular momentum we have p, or what, angular momentum equals I omega. So angular momentum of star a equals to angular momentum of star b, or else we can just so angular momentum of star a, sorry, no, that's not the way, star a divided by angular momentum of star b as shown in this particular ratio that they have given. So angular momentum of star a divided by angular momentum of star b, IA divided by IB should be multiplied by omega a divided by omega b. So I can't remember what the ratio of inertias were. So that is 2. Yep. IA over IB is 2. Where are you going? IA over IB is 2 and omega a divided by omega b is 3. Thereby the answer is 6. So angular momentum of star A divided by angular momentum of star B is 6. Alright. Question number 18. Under mechanics, circular motion, a circular disc of 0.5 meter rolls with uniform angular speed of 2 rads per second on a horizontal surface without slipping. The 2 points P and Q are located on the perimeter of the disc. The speeds of the 2 points relative to the earth when they are at the position shown in the figure. So once the wheel has a angular velocity of 12 rads per second, the linear velocity can be found out using V equals R omega. We know omega, so V can be found out, and the radius has already been given, 0.5 radius, angular speed 12, that means 0.5 5 into 12 equals 6 ms minus 1. A wheel rotates at v velocity relative to earth. That it means that its center moves at v velocity relative to the earth. If we take the velocity of wheel as 6 ms minus 1 and the velocity of p is going to be 12 and the velocity of q is 0. That means once the tire or the wheel is like this, we'll name the point, this q point, this is as p point. This rotates like this and this has a velocity of 2v, this has a velocity of v. So once the v here is 6, here it's 12 ms minus 1, here 6 ms minus 1, here the velocity is 0. Okay, these are the points. Okay, because theoretically it is something like this. Here 2v, if v, here v equals 0. This is the concept. So the answer, what they ask is positions, 2 points represent their position shown in the figure. P position and Q position. At P position 12, Q position 0. So answer is number 5. We asked about the P position and the Q position only, not this position. Question number 19. The graph shows a variation of force F exerted on an object P when it is moving along x axis from x equals minus 5 up to x equals plus 5 is the displacement and the work done on the object. So the work done. Work done. 19. Work done is actually force into distance. Okay, so force is exerted from here 0, minus 1, it's minus 2 here, 1, 2, 3 here, right? So from minus 2 to minus 3, there's a difference of 5 meters. So distance is 5 meters and the force they have given as the force here, this y-axis represents the force, x-axis represents the displacement. So force is 10 here, that's obvious, right? F is 10 newtons. Now just work done equals FD, that is 10 into 5, that is 50 joules. So the answer is number 4. Now we'll move on to question number 20. Final question to be discussed in this session. That is the box of mass 50 kg placed on horizontal flow bed of a lorry. The coefficient of static friction between box and the flow bed is 0.8 and the lorry accelerates along the straight horizontal rod. So coefficient of static friction given, mass given, and they are asking us to find the maximum acceleration so that the box will not slide over the flow bed. Maximum acceleration of the lorry to avoid slipping is A. I gave it as A. The box also accelerates with the same acceleration A. At that moment, the limited frictional force exerted on the object can be found out. Because the lorry travels in this direction, I'll apply F equals ma, and since they are talking about static coefficient friction, we can apply F equals mu r, and we can substitute this F with mu r in equals to ma. Here r equals, we know that the r equals to mg, because here when the box there's r force acting upwards, mg acting downwards, so therefore r equals mg. So mg substitute for this r, then ma equals to ma. Then you can cut off this m to m, and then you see that a equals mu g, and a can finally be simplified by applying mu value is 0.8 and g gravitational acceleration is 10, and then it is 8 ms minus 2 is the maximum acceleration the lorry can have, so that box will not slide over the floor bed. So that particular acceleration is what we just found out. So guys, that's all for today in this session. Hope to see you or meet you in the next discussion video. So all the best, good luck, and have a nice day.